explanation from my last video about how devices use electricity. If you haven't seen that video, I will add a link to that video in the description. In that video, we saw how different devices use different voltage levels. Let's check that out.
It's written 230V and 50 hertz. V stands for volts and hertz stands for hertz. This induction cooktop, 250 volts, 50 hertz. Amplifier, 60 hertz, 120 volts. It uses
My video on the screen there. It tells you how water got into the coconut. Link in the description.
A. A? What is A? A is amperes.
Those were all AC devices. Then we saw some DC devices like my mousey.
Hi, this is Mousey. Hi, Mousey. Let's see how much power Mousey takes. Oh, really? What's DC?
Then we saw some boring things like what is voltage and current. What is voltage? Voltage is a measure of electric pressure which causes current to move through the electric wires. Then what is current? Current is flow of electric charge in a circuit. Then some magic. Comparing water flow with current? Simpler. Let us compare current with water flowing through a pipe. A wire through which we get electricity is generally made of copper. Then I gave the complete picture. Now a recap. Electric charge is an electric particle stored in a voltage source like the battery. The level of charge stored in the battery is called voltage. When we connect a wire and complete the circuit, the charge flows through the wire and this flow of charge is called current. The current will help the appliance like this bulb connected in the circuit to run. Now that is simpler. Let's now look at AC and DC. There are two types of electricity, AC and DC. If you look at this battery, you have polarity. One side is positive, one side is negative. And the voltage of this battery is 1.5 volts. When you use this battery, you will get a voltage of 1.5 volts and current flows only in one direction, from the positive terminal to the negative terminal. This is called DC or direct current. All the appliances like our toys, torch, mobile phones, Kindles use DC power. All of these are powered by batteries kept inside them and they supply DC power. Battery comes in different sizes. This is a AA size battery. It is very common. This is a AAA battery, which is also smaller. And then you have big guys like these, and even bigger ones, and even bigger ones, and very big ones, like this inverter battery. Then you have smaller ones called button cells. Wow, yeah, they are very small. There are even smaller ones, like this. Hope you can see it. It's too small. I told you there are two types of current, AC and DC. Then what is AC? AC is called alternating current. In alternating current, the direction of current flow is alternative. Means it flows in one direction for some time and then it flows in the opposite direction for the same amount of time and the cycle continues. But how does the current flow in opposite directions? That is because the voltage changes polarity. It is like a battery rotating in this circuit. So for some time the current flows in one direction, and when the battery rotates to the other side, the current flows in the other direction. How many times it changes direction is called frequency, and it is measured in hertz. You remember I told you about hertz? The cooktop takes 50 hertz, and then my Mac takes 50 to 60 hertz, and the amplifier takes 60 hertz. Remember my Mac used 1.5 A? A stands for amperes. Amperes is the measure of how much current flows through the circuit. Since we alternate and change directions of the current, it is called alternating current. If it is alternating, then the current is not going anywhere. It goes and comes back, goes and comes back, but it remains in the same position. And how can it do any work? Water has to flow to do any work, but current is not like water, that it has to flow from end to end. The electricity just moves, it makes energy, which can be used to power appliances. Most of the appliances used at our home like motor, light bulb, fans use AC power. There are some appliances that take AC power and convert to DC internally to use it. Although appliances like television, computers, or even your laptops take AC power from the plug sockets, but internally they convert it into DC. If most of the appliances can run on DC, why do we need AC? Good question. AC is very good at one thing: traveling over long distances. DC power is very bad at that. The power sources are several thousand kilometers from our cities, and they are able to distribute the electricity over this long distance only because it's AC. If it is DC, we would need a power source every 1 kilometer, which is not practical.
There are differences how electricity is designed in different countries. There are two AC levels used in different countries. Most of the countries in the world use 220 volt, while US and a few other countries use 110 volt. 110 volt was considered to be safe, but transporting 220 volt was cheaper, so some countries chose to use one or the other. Remember the induction cooktop we saw? It worked on 230 volt AC. If I take this cooktop to US, it will power on, but it will not heat enough, as in US the voltage levels are 110 volt AC. Now look at the amplifier we saw in the beginning of the video. This one needs 110 volt. If I connected it in India, then poof, some smoke will come out of it and it will burn. So we need a converter like this one. The converter converts 230 volt AC to 110 volt AC.
So the problem due to this difference is for us. If I buy something from US, I cannot use it in India, or if I buy in India, I cannot use it in US. But it is also difficult to make countries change from one voltage scheme to another. So instead, some companies came with a smart idea. Remember the power needed for my Mac? It can take power from 100 volt to 30 volt AC. My Mac, my Alexa, my Nintendo Wii, my modem, and most devices of today support 100 to 230 volt, and I can use it anywhere. So I don't need this converter anymore.
Now if I take my Mac to US, my power adapter can support from 100 volt to 230 volt AC. So I should be fine, right? No, there is one more difference. The plug in US is different from India, which is different from Europe, which is different from East Asia. Different countries have different type of plug points, about 15 of them. So if you carry your laptop from India to US or Europe, the power adapter won't fit. You will have to buy an adapter. Now you have travel adapters or universal adapters like this one, which can be set for any country.
This is a universal adapter. This one will work in India, Korea, Germany, and France. This one will work in UK, Dubai, Malaysia, and Singapore. And some others. This one will work in Australia, New Zealand, China, and Argentina. This one will work in the US, Canada, Mexico and Japan. So what did we learn today? We learned about different units of electricity like volts for voltage, ampere for current and hertz for frequency. We also understood the two types of electricity, AC and DC. We saw different appliances have different power ratings. We also saw different countries have different power ratings and even different adapters.
That's a lot of electricity for a day. I am shocked. In my next video, we will make a real electric circuit with components like capacitors, resistors, LEDs and many more. That's all folks. Thanks for watching. Hope you liked this video. Then please hit the subscribe button and then I will notify you when I add my next video.